This video will orient you to the Automata box provided to you for installing cams and animating cam motion. The box is designed to accommodate up to 4 cams and has a clear acrylic top for enhanced visibility of cams and followers. There is a crank on the left side that turns an axle. Each cam you assemble onto the axle will contact a roller. The roller is attached to the end of a follower, so both slide vertically with the cam motion. The rulers mounted behind each follower can be used to measure the follower displacement. As the crank is turned, a bezel graduated in 30-degree increments can be used to measure the crank position. The crank can be manually turned with a mouse click and drag. Expand the joints folder to access the axle revolute joint. Right-click Rev 9 and select Go to Home Position to return to the initial joint angle. For continuous smooth motion, right-click Rev 9 and select Animate Model. Press the Escape key on the keyboard to end the animation. The crank can be set to specific angles. Right-click Rev 9, Edit Joint, and enter the desired angle, and OK. Components are organized into groups in the timeline. Identify the group by clicking a component and observe the marker over the group. Expand that group to see the component timeline. The 0 position of the 4 rulers can be changed by identifying its group, expand the group, and edit the extrusion. I'll select the Undo button to return to the original extrusion length. This video should orient you to the Automata box as you prepare to install cams and animate cam motion. Cam to the approximate position. This video will guide you through a procedure to assemble cams and animate cam motion. Upload the Automata box into your active folder and then open the Automata box model. Drag a cam into the design. In this example, the pear cam is used. Move the cam away from the box to better select its geometry. Select OK. Click Close the data panel. If the crank and axle were rotated out of its original home position, where 0 degrees is oriented along the positive z-axis, then you will need to reset this position. Open the Joints folder, right-click the revolute joint that defines the relationship between the axle and crank bushing, which is Rev 9 in this example. Click Go to Home Position. Note if the axle is already in the home position, then this option is not shown. Close the Joints folder. Zoom in to see more detail. Click Assemble. Under the Motion tab, select Rigid as the joint type. Return to the Position tab, then click Select Component 1. On the cam, select the center of the hole for the axle. Notice that as the cursor is moved close to the hole, the selection option changes. Use the option shown with a black circle and a center mark. Click the center of the end of the axle by the crank using the same selection option with the black circle. The outside face of the cam needs to align with the end of the axle. If needed, click the Flip setting. Click the arrow that aligns with the axle, then drag the cam along the axle. Notice the Offset Z entry box changes. The value needs to be 1.25 inches to align the center of the cam and follower roller. Drag the cam to the approximate position, then enter the value using the keyboard. The minimum radial distance needs to be oriented to the top of the box. Update the angle field to orient the cam for this condition. Click OK. The roller needs to rest on the cam perimeter. The slider joint must be edited to be the current offset plus the distance between the roller and the cam perimeter. This distance was previously calculated to be 0.475 inches. Open the Joints folder again. Find the group of 4 slider joints, then locate the slider joint of the leftmost cam. An efficient way to locate this joint is to select the joint and observe the joint preview information on the model. Position the model to see the follower guide and the roller. Right-click the joint and click Edit Joint. The Z offset is currently 1.5 inches. Add 0.475 inches to the current offset, which will become 1.975 inches. Enter the new offset, then click OK. Orient the automata and zoom to confirm that the roller is in contact with the cam. It helps to uncheck the visibility of the box left and right ends. Right-click the same slider joint. Click Edit Joint Limits. Click Rest and use the default 0 inches to define the initial position. Click Maximum and enter the maximum displacement of the cam based on the pair cam geometry. This distance was previously calculated to be 0.25 inches. Click OK. Click Assemble, then enable all contact. Scroll up in the browser and you'll see Contact All shown. Reposition the model for a better view of the crank, cam, and follower. The crank can be turned manually by click dragging the crank. To return to the home position, right-click Rev 9 and go to Home. The crank can be smoothly turned by the software. Right-click the Revolute joint, Rev 9, click Animate Model. Press the Escape key to stop. The crank can be set to a specific angle. Right-click the Revolute joint, Rev 9, click Edit Joint, enter an angle such as 30 degrees, and OK. The crank moves to the position. To return to the original home position, click Edit Joint, enter an angle of 0 degrees, then OK. The rulers behind the followers can be used to measure the displacement of the followers. Use the ruler spacer to set the 0 mark of the ruler. Identify it, expand the group, then select the offset that you wish to use. And that will change the 0 point of the ruler. To return to the original position, edit the extrude, then update the distance to be 2 inches. You should be prepared to assemble cams and animate cam motion.